Okay, so first we have to understand what exactly the OSPF LSA is. Okay, so OSPF LSA is an OSPF packet type which contains your OSPF link state information. What exactly it contains? Your OSPF link state information. That means on which link, what state they are running. Okay, on which link, what network you are advertising, on which link, which area you are advertising. Okay, all those information are exchanged. Am I audible? Hello?
Bit low.
There you go.
Sir, not clear, sir. Your voice is.
Hello, 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 hello. Is it clear now? Hello?
Yes, sir. It is clear now.
It is clear. Okay. Let me go then. Okay. So what exactly the OSPF LSA is? LSA is an OSPF packet type which contains your link state information. That means whatever the information OSPF is being exchanged, whatever the information which OSPF routers are exchanged with its neighbor router, all those information are exchanged in the form of LSS. In the form of LSA. LSA stands for what? Link state advertisement. Okay, the name says what exactly it means. It advertises its link state information to its neighbor router, which are directly connected to it. Okay. So first one is what LSA is an OSPF. Okay. So now what they have done. Okay. OSPF LSA contain lots of information. So that is why they have that is why they have done what? Okay, they have created the complete OSPF LSA into a different parts. And those parts are like type 1, type 2, type 3, 4, 5, 6, 7, 8, and 9. Okay, total there are 11 different types of LSA in OSPF. Total 11 different types of LSAs. Okay, why they have created total different 11 LSAs? Okay, because LSAs contain a lot of information. Okay, LSAs contain a lot of information, so they have decided to make it into a small pieces, and those pieces are known as what? Types. Okay, and total there are 11 different types of LSAs in OSPF. Okay. So the first LSA type is router LSA. The first OSPF type is the first LSA type is router LSA, OSPF router. What exactly the router LSA? Okay, so first point it says every router of OSPF, whether it is your area border router, autonomous border router, or a regular router, whatever the router is, every router generate a type 1 LSA for the area which it belongs. For the area which it belongs. Okay, so every router of OSPF is going to be generate type 1 LSA for the area which it belongs. Okay, so for example, if your router belongs to area 1, so for area 1 it will generate a type 1 LSA, and in that LSA it will contain what? Area 1 information. If a router is a participant of two different areas, so it will create two different type 1 LSA, one for area 1, one for area 2. Okay, area 1, whichever the link is configured for area 1, on that link it will flood type 1 LSA. Whatever the link is configured for area 2, on that link it will flood type 2, uh, type 1 LSA for area 2. Okay. So what it says, the router LSA is generated by each router for each area it is located. Okay, the same thing. In the link state, you will find the originating router's ID. Now, what exactly the router ID means? What is router ID? Anyone? In OSPF, there is a concept of router ID. What exactly it means? Anyone? Yes, guys. Router ID. Simple, very simple. Router ID, which is used to identify a router, which is used to identify a router in OSPF process. Every router have a router ID. Every router has a router ID. What exactly it is? It is one of the IP address which is configured on your router. It is one of the IP address which is configured on your router. Now, on your router, hundreds of IPs are configured. Then every IP will become a router ID of a router? No, it
No,
should
no,
be only
highest IP,
one.
sir,
Highest IP of what?
of the interface,
Tell
sir.
me the complete. Tell me the complete sentence. I can understand the highest IP address, but what highest IP address?
Sir, fast octet is higher. Which one is fast
Last
octet
octet
is
is
higher?
higher. Okay. The condition is first it will check for the logical interfaces. Okay.
Yes, loop based.
Whatever the logical interfaces are present on router, is it? Whatever the logical interfaces are present on the router, onto this, okay, they will select one of the highest IP address. Okay, if no logical interface is present, then it will move to what? Physical interface. Okay, over there, whatever IP address is configured with highest IP address, highest in numeric number, okay, that IP will become a router ID of your router. Okay, if you don't want this election to be done auto, okay, you can set it manually also. Okay, inside router OSPF, you have to give a command router ID, then you can set it manually also if you want. Okay, so router ID is the ID which is used to identify the router in OSPF process. Okay, the condition to be a router ID, first it will check for the physical IP, physical interface, logical interface. In logical interface, whichever interface with the highest IP address, that IP address will become your router ID. If no logical interface is present, if no logical interface is present, then it will move to physical interface. Out of those physical interface, whichever interface is having the highest IP address, okay, that highest IP address will become a router ID of your router. If you want that election should not be auto, you can set it manually by putting a manual commands. Okay, how to set the router ID, that we will see. So type 1 LSA, every router generate type 1 LSA for the area which it belongs to. Okay, and it contains what? Its area information. Its area information, local area information. Okay, also it contain what? The router ID of the router. Okay, see, let me, if we will. Okay, like this. Okay, routers are connected back to back with each other. Okay, but into a different, logically we have divided with the areas. Okay, so type 1 LSA says, type 1 LSA says, okay, every router will generate a type 1 LSA for the area which it belongs to. Same, router 1 will generate a type 1 LSA only for the area which it belongs to. That means it will flood its own information, but only within an area. Similarly, router 2 also on this interface, if you have configured this interface for area 1, it will only flood that information, type 1 LSA information within an area. Okay, it will never send that area information in this interface or in this area. Similarly, router 2 will generate two different type of an LSA, one for area 1 and one for area 2. Here they will send type 1 LSA, but that is for area 2. Similarly, here also type 1 LSA for area 2. This router will generate another type 1 LSA, but for area 3. Area 3. This is the reason two different regular areas are not able to communicate with each other. Why? Because type 1 LSA is stopped on your area border router. It will never cross from one area to another area. Okay, so this is what type 1 LSA. Second one is what? Type 2 LSA, which is known as what? OSPF network LSA. OSPF network LSA. Yesterday we have discussed something about DR and BDR. Okay, when you have a BMA topology, broadcast multi-access network, there will be a election of DR and BDR, designated router and backup designated router. There, a responsible person is what? DR, to control the entire topology. And yesterday we have also seen DR will always send an update on multicast address of 224.0.0.6. Okay, 224.0.0.6. So similarly, here also, when you have a DR and BDR type of a topology, that means BMA type of a topology, DR will always send LSA in the form of type 2 LSA. In the form of type 2 LSA. Okay. So the next routers which will receive it, it will automatically understand this information is coming from DR router. This information is coming from DR router, designated. Network LSAs are generated by the DR. It is only responsible to generate by DR, not with any other router. In any different topology type, like point to point, or if it is multi-point, or if it is NBMA network, okay, there you won't never find a type 2 LSA. It will only happen in your BMA topology, where only DR is responsible to flood it. Okay, so the link state ID will be interface IP address of the DR. Okay, the link state ID will be interface IP address of the DR. So type 2 LSA, only DR generate, okay, to inform every other router or to update every other router in your BMA topology type. Next, type 3 LSA, which is known as what? OSPF summary LSA. OSPF summary LSA. Can anyone explain me what is OSPF summary LSA? Till the time I will have a glass of water. Okay. Yes, anyone? Type 3 LSA? Anyone? Any point? Yesterday only I told you guys, Just try to remember only one pointer from every LSA. Just type 3 LSA.
Okay, so the type 3 LSA is being sent. It's sent between areas just to announce the route from one area to another area.
Very good. Okay, who created this type 3 LSA? Who created this type 3 LSA? Who created?
So it's created by the ABR, the Autonomous Border Router.
Very good. Very good. Now you can mute. Okay, so type 3 LSA, it is only generated by your area border router. Now in this topology, we have two area border router. One is this one, okay, and one is this one. Okay, only area border router is responsible. Only area border router is responsible to flood type 3 LSA, where it contains one area information to another area. Okay, like if you want to exchange area 1 information in area 2, which is not possible, but for example we are taking over here. Okay, if you want to exchange area 1 information into area 2, okay, so only area border router is responsible to flood that information onto an area, a complete to everyone. It is the responsible to flood. Okay, if you have a 50 router in middle of this, okay, nobody will generate type 3 LSA. Only area border router will generate and flood throughout the area and it will stop over here. Next, this router will generate again type 3 LSA and flood throughout the area 3. Okay, so only area border router is responsible to generate type 3 LSA. What it contains? It contains one area information to another area. Okay. Next, type 4 LSA, which is known as what? Summary LSA. Type 4. Type 4 LSA, which is known as what? ASBR summary LSA. Now, what exactly it is? Anyone? Type 4 LSA? Any one of you? ASBR summary LSA. ASBR summary LSA.
ASBR summary LSA.
Yeah.
Generated by ABR.
For what?
Area border router.
Who?
Generated by ABR.
For what?
Who is reached in the autonomous system border router, ASBR.
Okay, very good. Type 4 LSA, which is known as what? ASBR summary LSA. Okay, it is only generated by type 4 LSA is only generated or it's only flooded by ASBR router, area for not. Type 4 LSA, it is not generated by ASBR. Type 4 LSA is not generated by ASBR. Okay, it is only generated by, okay, this router.
Generated by ABR, area border router.
Area
LSA4. Yeah, LSA4 ASBR summary LSA is generated by area border router.
Area border router of the area where ASBR is connected. Of the area where ASBR is connected. Okay, this is the condition. If you will say ABR router. So this is also the ABR router and this is also the ABR router. Okay, so it is generated by, in a simple word, okay, it is generated by the ABR router of the area where ASBR is connected. Where ASBR is connected. It contains the information. It contains the information or the router ID of ASBR. The router ID of ASBR, informing every other area or every other OSPF router who the ASBR is. Who the ASBR is. Got the point? Okay. Type 4 LSA, which is ASBR LSA. Okay. It is generated by the ABR router. It is generated by the ABR router of the area where your ASBR is connected. Where our ASBR is connected? What exactly the ASBR is? Okay, the router which is connected with another routing protocol. Okay, a router which is connected with non-OSPF routing protocol. So the router is what? This one, which is connected with non-OSPF routing protocol, which is what? RIP. Okay, so in our OSPF topology, this router is named as ASBR router, autonomous border router. Okay, every router should have information about ASBR. Every router should have information of ASBR, who the ASBR is. Okay, to inform every other router, they created a special packet type which is known as type 4 LSA, which is known as type 4 LSA. Now, who will generate this? The area border router of the area where your ASBR is connected. Where your ASBR is connected. Okay, so your ASBR is connected. Your ASBR is connected in this area 1. Who the ABR of this area? This router, the router 2. Okay, so it will flood type 4 LSA. It will flood type 4 LSA in every other area, informing every other router who the ASBR is. What is the router ID of ASBR is? Okay, any doubt? Answers, please. Any doubt? Nobody. I think nobody is listening.
Sir, what is the need of this information? Because the OSPF protocol will not communicate with the RIP.
But you can make a communication between them. But you can make a communication between them. Very good question. What is the use of? I want a question from you guys. Right? Because I can't explain you each and every point. I can't remember each and every point. So when you guys will question me, then only I can explain myself. Okay. So what is the use of a type 4 LSA? What is the use of a type 4 LSA if your router is not able to communicate with a RIP? A very valid question. Okay. In future, we will see how a RIP will communicate with OSPF and OSPF will communicate with the RIP. Okay. There, when they two will communicate with each other, this router will send information of RIP, to every other router in OSPF. Understanding? This router will send information of RIP when you will make a communication between these two different routing protocols. Okay, this router will exchange a RIP information to every other router in this topology, in OSPF topology. So every other router will receive information of RIP with whom? From where? From ASBR router. From ASBR router. At that time, how they will identify whether this information is coming with a common router or with an ASBR router. Okay, at that time, how they will understand whether this information is coming with a common OSPF router or with ABR router. Okay, so that time this type 4 LSA is needed to identify, okay, what your ASBR is, who the ASBR is. Got the point? Hello.
Got it, sir.
Got it? Okay. Very good. Always
Okay,
ask
so
me questions.
sorry.
Always ask me questions.
Yes. So does it mean that the ASBR router does some kind of redistribution or?
Yeah, redistribution we will do on ASBR router only.
Okay. So supposing I have two routers in the network where one does they all do redistribution. So how do I identify? How does the
like this you are saying? These two routers? Yes, bro. Tell me. Explain me over here so I can answer you clearly. I'm audible? Hello?
Yes, sir, you are audible.
Very well. Actually, I didn't understand its requirement. Yes, you there? Can you please explain me the requirement so I can explain you clearly? Okay, everyone understand about type 4 LSA? Type 5 LSA. Okay, which is your external LSA. Type 5 LSA, which is your external LSA. External LSA, type 5 LSA, which is what? External LSA. Now, what exactly the type 5 LSA is? Okay, which flood the non-OSPF routing information. Okay, which what I explained you now. Okay, and this OSPF type 5 LSA is flooded throughout the area only with the ASBR router. Means this type 5 LSA is only generated by ASBR router. Okay, what it will contain? It will contain the non-OSPF routing information. Okay, so every other router, whenever they will receive any network information,
not audible,
type
sir.
5 LSA. Hello.
Sir, not audible.
Hello.
Sir, your voice is too low.
Voice is slow.
Too low, sir.
Too low. Hello. Now. Hello.
Still not clear.
Still not clear. Hello.
A little bit.
Yeah, hello.
Is my voice clear?
Sir, little bit better.
Little bit better.
Perhaps your mic is too far away from you.
No. It is in the same position.
It sounds like that.
Okay. I think okay. Type 5 LSA, which is only responsible to be generated by the ASBR router. Okay. ASBR router is responsible to generate the type 5 LSA, where it will inform every other router about the non-OSPF routing information. Okay. So whenever this router will receive any information with the type 5 LSA, they will automatically understand with the type 5 LSA, they will automatically understand this information is coming via ASBR router through type 4 LSA. How they will identify the ASBR? Through type 4 LSA. Okay, so they will.
Please, I have a question.
So, tell me.
So about the diagram that you have. Earlier on we said
This
area
one?
0 is. Earlier on the other time you said area 0 is always needed, so that you can send routes between two different areas. But in your diagram,
yeah.
I can't see any area 0.
No, bro. In previously only at very first only, I told everyone. Okay, this is the example. Okay, and while briefing this topology, I clearly told, okay, a communication is not possible, but for example, I created this. Okay, yesterday I told you area 0 is needed. That is very true. And in this topology, a communication is not possible. Okay, this is just an example I have drawn. Okay, bro.
Okay.
This is just an example. I'm just taking an example.
Okay, that's fine. Right.
Type 5 LSA done. Okay. So whenever a router will receive information through a type 5 LSA, they will automatically understand this information is coming. This information is coming with a type 5 LSA. Okay, so they will mark that information as an external network, external. Okay, and to receive a type 5 information or the external information, type 4 LSA is needed. Then only you will identify your ASBR router, who the ASBR is. Okay, and then only you will mark that network as an external networks. Okay, so here if you if you will see your routing table, in your routing table you can see 3 different types of routes. In routing table you can see 3 different types of routes. Yesterday I told you one is what? O routes, which is what? OSPF. Anyone? OSPF, which route it is? In RIP we have seen R. In EIGRP we have seen D. In static we have seen S. Every networks are marked with S mark. Okay, in OSPF we have a different types in routing table of OSPF. Okay, one is O. O is stand for what? OSPF. Intra-area routes, OSPF intra-area routes. For example, okay, if your router belongs to area 1, and if you will receive any information within an area 1, so that routes are marked as O routes. Okay, and this information you will get through which LSA type? Yes, tell me. Now I want answer from you guys. Same network information you will receive through which LSA type?
One.
Area 1? Oh, sorry, type 1?
Type 1. Yes.
Okay. Why? Because type 1 is responsible to flood within an area. So whenever you receive any information with a type 1 LSA, you will clearly mark that route as O routes. Okay. Second is what? OIA. Now OIA stands for what? OSPF inter-area route. OSPF inter-area routes. Now what exactly the OSPF inter-area route, and through which LSA type you receive this information? OSPF inter-area routes. the routes which are coming with a different area. The route which is coming with a different area. For example, if your router belongs to area 1 and you are receiving a route from area 2. Okay, so that means what? A route which are coming with a different area. Who is responsible to flood that information? Through which LSA type you will receive that information?
Type 3.
Huh? Type 3. Very good. Type 3 LSA. Okay, type 3 LSA, only ABR router is responsible to exchange a route from one area to another area. Okay, and the last one is what? OE routes. OE. There also you have two different types, OE1 and OE2, that we will see afterward. But here it is what? OE routes. OSPF external routes. Through which LSA type does we get it? And what is OSPF external routes?
This type 4 and type 5 both are responsible.
Type 4 and type 5.
Yes.
Type 4 is not responsible to send any network information. It will only send the ASBR information, only ASBR router ID information.
But after type 4, it will mark the external route, area border ASPR route.
No. Type 4 will only inform every other router. Type 4 will only inform every other router who the ASBR is. Who the ASBR is. That's it. Who the ASBR. Through type 5, they will flood external information. That means RIP information. Through type 5, they will flood. They will means what? ASBR router. Okay, so when ASBR router will inform every other router, so they will mark that route as OE routes. They will mark that routes as OE route. Okay, so external routes are coming through type 5 LSA, not with the type 4. Type 4 is responsible to flood the ASBR information, not the external routes information. Getting my point?
Got it, sir.
Don't be get confused. If you have a doubt, tell me. They are to clear.
Again, voice is bad concept.
Hello. Now is it good?
Yes.
Okay. Type 6 LSA, OSPF a different value. Okay. That we never deal with. Type 7, OSPF not so stubby area. Okay, there are some special areas which are what? Stub. Which are what? Stub area. One is totally stub area. One is NSSA, not so stubby area. And one is totally NSSA. Can anyone define this? Stub, totally stub, NSSA, totally NSSA. What exactly does it mean? No one? Okay. I will explain first. Type 7, which is what? Not so stubby area. Okay, that time I will define you what exactly the type 7 means. Okay, type 8, OSPF external attribute LSA. Okay, here also we don't deal with.
What about type 6?
Type 6, we never deal with. MOSPF, multicast OSPF. Okay, when you do a multicasting, there is a separate topic of a multicasting. So when you do a multicasting in OSPF, okay, we are not talking about the multicast address which OSPF use. A separate topic is known as what? Multicasting. Okay, so whenever you do a multicasting where OSPF is running, okay, there they use a separate LSA type to exchange the multicasting information, and that LSA type is known as what? Type 6 LSA, multicast OSPF LSA. Type 7, there is not so stubby. So when we do the NSSA, Okay, a special area type. That time we will see what OSPF NSS. Type 8 OSPF external attributes. Let it be 9, 10, and 11. I told you OPEC LSA, they have created this for future upgradation. If they came or if they come with some upgradation in OSPF, they will introduce in this LSA. Okay, so LSA is clear for everyone. You guys have to remember starting a 5 LSAs. Starting of 5 LSA. I'm telling again and again. Type 1 router LSA, which is used within a same area, never crosses area boundary router. Type 2, which is generated by DR router to inform every other router in BMA topology. Type 3, which is generated by ABR router to exchange one area information into another area. Type 4 LSA, ASBR LSA, which is used to inform the ASBR information. ASBR, not the network information. ASBR information. And what it will inform regarding ASBR? The router ID of ASBR. Okay. Type 5 LSA generated by ASBR router. Type 5 LSA generated by ASBR router to inform the external routes. To inform the external routes information. External routes. That means what? The route which is coming from non-OSPF routing protocol. It can be your RIP, it can be HRP, it can be static, or it can be any BGP or anything. Okay, if they enter in your OSPF, they will mark the as OE route, OSPF external route. That means it do not belongs to OSPF routing protocol. They are coming with some different routing protocol. And who is responsible? Only ASBR router is responsible to flood that information throughout the OSPF. Throughout the OSPF. Type 6 MOSPF, let it be.
Explain type 2 again.
Type 2 LSA, which is flooded by DR router, DR, designated router. Yesterday we discussed about the DR and BDR. Okay, let me explain you again the DR and BDR process in depth. In depth. Okay, let me explain you. Give me a minute. Let me draw topology. Okay. Now in this topology, this is what my BMA network, broadcast multi-access network. Now what basically happens in OSPF topology? Okay, now what basically the process of OSPF is? Okay, the first process of OSPF is to be a neighbor with the directly connected routers. Okay, to be a neighbor with a directly connected router. Now this is what this switch is. Every router is connected with whom? Router 1. Every router. That means what? Router 2, which is connected to router 1. 3, which is connected to router 1. 4, which is connected to router 1. They all belongs to a same network, 10.1.1, 10.1.1.2, 3, and 10.1.1.4. Okay. Now what router 1 will do? Router 1 will flood a hello packet. What it will do? It will flood an hello packet saying hello to its neighbor router. Saying hello to its neighbor router. It will reach over here. It will reach over here. Is it or not? It will reach over here. Is it or not? Okay. Then router 2, router 3, router 4 all will send an acknowledgement. All will send an acknowledgement. Oh, hello. Router 1 said hello. They will say hi. We are there. Okay. Again, router 2 will do sending of a hello packet. To whom it who are the router which will receive? Router 1 will receive. Why? Because that information is getting broadcasted. They all belongs to what? A same network and connected where? On a multi-access network. Broadcast multi-access network switch. Okay. Then same process with router 3. You guys can assume how many different types of packets are getting generated in between only 4 routers. So for example, if you have 50 routers in this topology, what will happen? You guys can understand what will happen and how much load of traffic will come on your network. You guys can understand how much of traffic load will come onto your network. Okay. So for example, let them, okay, they have become a neighbor. They have become a neighbor. Okay. First process is done. Okay. Everything is working fine. Everything is working fine. Behind router 2, there is a one configured network, which is, for example, like 20 dot something network, which falls down. To whom it will inform? It will inform to every neighbor. Router 2 neighbor is router 1. Router 2 neighbor is router 3. Router 2 neighbor is router 4 also. Okay. What do you think? This process will end over here? No, this process will not end over here. What router 1 is thinking, router 2 informed me about the changes. Now my responsibility to inform my neighbor about the changes. Router 1 will exchange that same information with router 3, router 4. Same process will happen from router 3 as well. Once it will receive a packet about the changes from router 2, okay, router 3 responsibility to inform that changes to its neighbor router as well. And the same process will happen from router 4 also. When it will receive a information from router 2, router 4 responsibility to inform the same changes to its neighbor router. So you can assume how much of a traffic is generating in between only 4 routers. So if suppose you have 50 routers or 500 routers connected in this topology, so what will happen? Getting my point? That means this is non-manageable network. This has become what? Non-manageable network. To make it manageable, in such a type of a topology, they came with the concept of DR and BDR. DR and BDR, backup designated router. Okay, so what it will do, it will make one of the router in a complete topology as a DR router. So whatever a changes will happen, whatever a changes is there, okay, that changes you have to inform only to DR router, then DR router will flood that information to every other router. Through what? Type 2 LS. Through what? Type 2 LS. So for example, if suppose this is your DR router, how this will become a DR router? That I will explain you after. Okay, if this is your DR router in a topology and anything happens on your router 2, okay, router 2 will only inform to whom? The DR of the topology. Now DR of the topology will inform to every router and the process will end over there. That's it. Additionally, they have configured the BDR router as well. Why? Because in future, if DR link will goes down and DR is not reachable, then whom you will inform? So once a DR is not reachable, automatically your BDR router will become a DR router. That means it will hold a responsibility of DR router. Got the point? Things are clear?
Yes, sir.
I have a question.
Yeah.
Is it possible that we can forcefully make any DR or BDR?
Come again, come again.
I was saying, is that possible? We can make any DR or BDR forcefully, like
Forcefully, yeah, you can
automatic.
make. You can make any of the router forcefully as a DR router or BDR router. Okay, you can make any router forcefully as a DR router or BDR. Okay. Now let me explain you what is the condition or criteria to be a DR router. Okay, if you are not making it forcefully, what is the condition or the criteria to be a DR router? Okay, so the first condition is highest priority. Highest priority. The first condition is highest priority. Okay. Every OSPF router have a default priority of what? Default priority of one. Every OSPF router have a default priority of one. For example, okay, this router has a default priority of one. The other router, same one. That means on every router you have configured the default priority of one. Okay, so there will be a tie, okay, between the routers. Okay, so as a tiebreaker, they will use the second condition, and that is what? Highest router ID. The router IDs are different on every other router. Okay, for example, on this router, this is the router ID, this is the router ID, this is the router ID, and that is the router. Okay, now as per the condition, in this topology, this router is eligible to be a DR router. This router is eligible to be a DR router. Backup designated router, second highest priority or second highest router. So which router? 10113. This one is having the second highest router ID in this topology. So this router will become a backup designated router. Okay. Now, if suppose forcefully you have to make this router as a DR, you don't want this election to be held like auto. Okay, you want to forcefully router 1 should be a DR router in this complete topology. Okay, so what you will do on this router, you will increase the priority of this router with 100. With what? 100. You can set a priority from 0 to 255. From 0 to 250. The default priority is 1. Okay, if you want any router to be a forcefully as a DR router, change its priority. Why? Because this is the first condition. This is the first condition. Got the point? Is it clear now, Pratik?
Yes, sir.
Yes, sir.
Okay. So if you want any router to be a forcefully DR router, you can make it, okay, by changing it or by making highest priority of any. You can make a priority from 0 to 255 any. But if suppose you will make any router with a priority of 0, then what will happen? Anyone? That router will never participate in the election of a DR and BDR. Okay, if you want any of your router does not DR or BDR, make it a priority of 0. Okay, so that router will never participate in the making of DR and BDR.
Is there any advantage?
Is there any
Advantage?
advantage? No, not any advantage. If suppose, for example, you know, like this is the old version router, like a very old router. Okay, it has a very less memory or very less CPU. Okay, if you know that this router can't handle that much of responsibility, okay, so never involve that router in election of a DR and BDR. That is only the advantage. Got the point?
Got it.
Any doubt till now in OSPF LSA type in DR and BDR?
Okay. Hello. So my question is, supposing I have the DR router and I configure that router to redistribute other routes. Can I now call that router an ASBR and not a DR, or can it act as both ASBR and DR?
You want something like this or what?
Okay, so should I repeat my question?
Repeat, better repeat.
Okay, so my question is, supposing I have a DR router and then I configure.
So this is your DR router, okay? Slowly.
Yes.
This is your DR router. Let me understand your question first. Okay, this is your router, DR router. Okay, you are connecting this DR router with other router which is running a different routing protocol, right?
Yes.
Okay. Then?
Okay, so when this happens, can I now call the DR router an ASBR?
Yeah, this router will also become an ASBR router. Why? Because this is dealing with any other non-OSPF routing protocol. Yes, come on, another point.
Okay, so it means it will play the role of both ASBR and then at the same time DR.
Yeah, of course. It will play a role of same like DR as well as ASBR. Okay, so in this topology also, if I will explain in this topology also, if you have another router, okay, like this, and that area, this is what area number 4 for area number 4. Okay, now this router is playing a role of ASBR as well as ABR. Okay, ASBR for what? It is connected with the non-OSPF routing protocol. ABR for what? It is also connected with a different area. Okay.
Okay.
Any doubt? Anyone? Okay. So we will complete it today. Thank you, everyone. You guys don't have any doubt.
Hello, sir. If you don't mind, sir, actually, sometimes how to get recording this session?
You can contact to in your group. You can contact. Okay, in your group, sir. I think someone is there, Monica or something.
And what is the syllabus of this course?
Syllabus? Yeah. Don't worry, I will teach each and everything.
No. And after this course, we will get a certificate.
Then you can ask the guy or the person from which you have took this.
Sorry?
You can ask with the person, okay, from where you have enrolled for this.
Okay, sir.
Okay, because I don't have any information regarding that.
Okay, sir. Can you give me a particular link or particular number where I get all these information?
I think in your group, one lady known as Monica, I think. Who sent you the link in a group?
Actually, sir, yes, sir. I have lots of group and numbers, That's why I'm confusing. That's why I'm asking.
The person who send you the link in a group, okay?
Okay.
Contact me.
Okay, sir. Thank you, sir.
Okay. Thank you, everyone. Shall I end now?
Yeah. Sorry. Yeah. Hello.
Tell me.
Yeah. Please. So next time, can we go over the JSCRA